Welcome. My name is Christopher Rodman. I'm with the Carnegie Mellon University Software Engineering Institute. Today we're going to be discussing Living Off the Land, native Windows tools for blue team analysis. So a brief introduction. Living off the land, natively a term used by penetration testers to describe using readily available tools and techniques on a system to conduct tests on a target machine. Our objective today is to identify similar programs, scripts, and techniques to use on Windows-based machines, leverage these tools and techniques to collect information for incident response and forensic analysis. And this is particularly useful when commercial tools aren't readily available and installed on a system. I should also point out that these tools also facilitate the ease of use for when support personnel is not able to remotely connect to a machine or dealing with a non-standard asset. Our scope of today's talk is going to cover users and groups, logs and events, processes and libraries, programs, tasks and services, file system and registry, and finally network. Some brief considerations that we want to take beforehand and before we get started. Machine reboots and power cycling of an asset typically may clear vital data that is pertinent to the investigation process. In some cases, administrator elevation may be required to collect data outside of the user profile context. Firewall rules and access control list rules may prevent movement of data or remote collection of information. Local machine policies, user access control can restrict the ability to execute certain scripts and commands. And having baseline of system properties is extremely helpful in a lot of cases that we'll review today. To get started, users and groups. Again, to drive home the fact, initial baselines of local users and groups on a machine is imperative to help identify any anomalies within a system. Our goal is to identify local users, and then determine if local accounts have been created, and then identify any high-privileged group members, particularly around administrators and backup operators. To help us obtain this information, we can use a series of command line tools and PowerShell commands. Particularly in this case, command line tools such as netuser, netlocalgroup, and qwinsta can help us identify users, groups, and active sessions. Adversely, PowerShell commands such as getLocalUser and getLocalGroupMember can also help us gather this information. In this demonstration, we'll review a number of methods to retrieve local users and local group memberships on a Windows-based machine. To start, we'll leverage the netuser command to obtain local users on the system. As we can see here, we have a number of built-in accounts along with a couple of user-based accounts, namely bad user in this case. We can leverage the netlocalgroup command to enumerate any one of the local groups on a system. In this case, we'll enumerate the administrators group. As we can see here, we see the members of each member of the group. We may also want to enumerate other groups of interest, namely in this case, backup operators, as they also have high privileges on this machine. Additionally, we'll note that sometimes quotes are needed whenever there are spaces within a group name. Finally, we'll leverage the qwinsta command to obtain any connected sessions to a particular system. Alternatively, in the PowerShell console, we can run getLocalUser to obtain a list of locally created users on the system, similar to that of netuser. Additionally, we can run getLocalGroup to obtain current groups that are created on this OS. Finally, If we leverage get local group member, we can enumerate any group membership for each one of these groups on this operating system. You'll notice that the format's a little bit different in this case, but it still shows us the same general results. Moving on in our analysis, we would like to take a look at logs and events on the Windows machine. Particularly in this case, we would like to look at application, security, and system logs that may be pertinent to our investigation. Keep in mind that some log files require elevation to obtain through a command line interface, particularly the Windows security event log. And in addition to that, some logs are also dependent on explicit logging levels that need to be enabled or installed. Some of the examples of this are PowerShell logging or sysmon logging. For this particular analysis, we'll be leveraging the wevent-util command line program. And in addition to that, we can also leverage PowerShell commands for get-win-event and get-content. The differentiation between these two PowerShell commands is get-content will gather flat file information for us for logs outside of the Windows security, the Windows event log context. When we need to enumerate logs and events on a local Windows system, we can leverage a number of different utilities. In the command prompt, we can leverage wevt-util to search and filter through the Windows event logs on this system. The /? will show us the manual page for this particular program and give us a list of parameters that we can run with this utility. In this case, we'll run the QE parameter along with C:3 parameter to show us the application event logs and the last 3 events that occurred within that log. Over on the PowerShell side, we can run get-win-event to get us the same information as wevt-util. In this case, we'll define the application log within our command line parameters so that we can find similar information. Additionally, we can run get-content to find contents of log files that are text-based in nature. In this particular case, we'll get the content of the cdtc install log as an example. The advantage in this case that we have is that leveraging PowerShell allows us to pipe these commandlets and the output from them into other commandlets within PowerShell. Moving along, we can also analyze running processes and active libraries within the context of a machine. It is important for issues or attacks that may not persist in files and may rely only on memory-based attacks. Combined with network connections, we can determine if a machine has been compromised. But some of the key challenges in this case may be rebooting the machine, or that we need escalation in this case. Some commands that will help us identify some of this information are wmic, task lists, and from the PowerShell interface, get process and get wmi object. When we need to obtain process and library information, we can run a variety of different modules within the command line and PowerShell consoles. On the command line side, we can leverage wmic process list full to get a detailed list of each running process on this local system. This detail includes process name, process identifier, command line, and a number of different metrics for each running process on this system. If we need to obtain the process list in a different view with some additional information, we can leverage the task list command. In this particular case, we'll leverage task list with the /m parameter. As you can see here, we've obtained process name, process identifier, and loaded libraries for each process running on the system. Note that some processes do not have library information, as it may take an administrative command line in order to obtain that detail. On the PowerShell side, we can run get process to obtain a simple and straightforward view of the processes running on this current system. Additionally, we can run get process with the -include and username parameter to identify running processes for other users on this system. However, it is noted that this does require elevation in order to get information from other users outside the context of your own. Additionally, we can also get WMI object with the Win32 process class to obtain similar process information. Since this list is so detailed, we'll filter our results just for the PowerShell.exe process. As we can see here, this gives us a full in-depth detail as we saw with WMIC process list full. And we have, in this case, a particular PowerShell process that seems to be running some additional command line parameters. Next, we'll talk about programs, tasks, and services. We're essentially, in this case, collecting an inventory of program information. This information includes scheduled tasks and installed services. Again, determining baseline and tasks and services determine normalcy for a particular machine and allow us to identify anomalies after the fact. Again, administrative privileges may be required in some cases when requesting system scheduled tasks. And also, WMI can also be used in command and PowerShell terminals in this particular case. In this particular case, we have command line tools for WMIC, which we've previously used, task list /SVC, SC query, net start, and schedule tasks. From the PowerShell command list side, we have get scheduled tasks, get service, and get WMI object. When we need to obtain program, task, and service information from a local system, we have a variety of tools in both command prompt and PowerShell terminals. On the command prompt side, we can start by obtaining a quick list of the running services on a local system with the net start command. We can get additional detail utilizing task list again, this time with the /SVC parameter. As you can see here, this gives us a view into the process name, PID, and associated services on this system. Additionally, we can run SC query to obtain a queryable list of all running services on this workstation. And finally, when we want to search scheduled tasks on this system, we can run SCH tasks to obtain a list of all running scheduled tasks, their statuses, and runtimes. On the PowerShell side, we can leverage the getWMI object module again in order to obtain service information. Additionally, PowerShell also has a built-in module for getting services natively, utilizing the get-service PowerShell module. This allows us to obtain a little bit more verbose list of the running and stop services on this workstation. Finally, if we need to obtain the scheduled tasks on this workstation through the PowerShell console, we can leverage get scheduled task, get scheduled job, get scheduled tasks with a verbose switch to obtain scheduled task and additional detail. Moving along to file system and registry. File systems and registry components contain a wealth of information. Filtering and targeting our specific results are critical for efficiency in this case. Command line interface usage can also help us avoid inadvertently modifying any files. Additionally, PowerShell can query registry and certificate stores and also natively obtain file hashes without the use of any external tools. Some of the components that we'll be using today for file system and registry access is the net command, net use, net share, net session, the directory command, and reg query. On the PowerShell side, we can use get ps drive, get child item, and get file hash. Obtaining file system and registry information from a local system can be done in a variety of different ways on a Windows workstation. Starting on the command prompt, we can leverage net use to display any mapped drives present on the system. Utilizing the net share command, we can also query for the created and available shares on a local workstation. In this case, this gives us all the default shares on a Windows workstation and any user-created shares. Leveraging the net session command will also grab us any information for connected sessions to any open shares on the system. However, it does require elevation to be utilized. In order to query additional information from a file system, we can leverage the directory command along with specific parameters to help us query down and filter our result sets. In this particular case, we want to see what's in the C:\share directory to figure out if there's anything malicious here. If we need to query the registry, we can leverage the reg query command along with a specific registry key to find information out about that particular key. In this case, we may want to look at the auto start registry key to find out if there is anything set, any program set to execute upon login. In this case, we can see that the pspayload.bat file is set to automatically execute upon user login. Over on the PowerShell side, we can leverage get ps drive to show us a list of all available drives that PowerShell console has access to. As you can see here, in addition to the C and D drives, we also have access to the certificate repository and registry repositories that we can query similarly to file systems on a Windows system. Leveraging get child item will give us similar results to the directory command in the command prompt. Utilizing get item property can show us similar information to the reg query command. However, in this case, get item property can be directed to any registry key or other file system object that may have additional properties to it. In addition to these basic commands, PowerShell also has the ability to obtain the file hash of a particular file. In our example, we can see that the pspayload.bat file has a very specific SHA-256 hash. This can be used to query against a particular virus database or other exploit databases to find out if there are any valid matches. Finally, we can leverage get authenticode signature to obtain the validity of a particular file. In our example, we can see that the pspayload.bat file does not have a valid signer certificate. Therefore, this leads us to believe that this particular file is not valid in comparison to those created by verified publishers. Moving on to network, at a local machine level, network analysis can come in multiple different forms. Local ARP and DNS cache, adapter configuration, active and inactive connections, and finally a packet trace. Most information can be obtained without the need for administrative permissions in this case. And again, baselining normal activity is key in this scenario. Some of the tools that we'll be using in this particular scenario in the command line are ARP, ipconfig, netstat, netsh. And on the PowerShell side, get net adapter, get net TCP connection, get net neighbor, and get DNS client cache. Obtaining network information can be done in a variety of different ways on a Windows workstation. At a very basic level, we can run ipconfig/all to obtain all network adapter information from this local system. Utilizing ipconfig with the /display DNS switch can show us the DNS cache of this particular system. In this case, we can see that the display DNS gives us the result of a malicious DNS.com callout to a particular IP address from this machine. Utilizing the ARP command with the -a parameter can also show us the contents of the ARP cache on this local system. And additionally, we can utilize netstat with the -nao parameter to obtain currently connected IP addresses, their states, along with process PIDs associated with each connection. On the PowerShell side, we can leverage get net adapter to show us similar information as ipconfig did. Get net TCP connection will show us a list of currently connected IP addresses, their states, and associated PIDs on this workstation. Get net neighbor will show us similar results to the ARP cache command that we utilized earlier in the command prompt. Get DNS client cache will show us the results and contents of the DNS cache on this local workstation as well. Finally, one powerful tool that we can utilize on a Windows workstation is the netsh command. The caveat here is that this command requires elevation in order to leverage. But with this command, we can take a packet capture from this system natively without having to install any third-party utilities. Run netsh trace start capture and define your trace file location in order to start the trace. You'll notice that the trace configuration gives you a status of running, where your trace file is located, and additional details around the capture. When your tests are complete and you need to stop the trace, run netsh trace stop to terminate the trace. You'll notice here that this particular process to build the trace from the collected information does take a few minutes to run, so we won't wait for it to complete in this demonstration. Finally, in conclusion, the data has been gathered. Now what? We can use these commands to create easily to use and deployable scripts. We can deploy it to machines within our organization for local and remote execution. We can even log this information for later analysis. We can collect that information into a log aggregator or a database, or we could even simply compress that information and email it to a SOC analyst. We can further automate and create workflows based on some of our findings. We can leverage RESTful APIs for additional action in this case, like creating firewall rules. And this concludes Living Off the Land, native Windows tools for blue team analysis. Thank you.